Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to solve the given Legender's differential equation. So let's get going. Problem solve 3x plus 2 whole square into d square y by dx square plus 3 times 3x plus 2 into dy by dx minus 36y equal to 3x square plus 4x plus 1. So we are given a differential equation of the form ax plus b power n into d power n y by dx power n plus p1 into ax plus b power n minus 1 into d power n minus 1 y by dx power n minus 1 plus so on plus pn into y equal to some function of x. We are given a differential equation of this form, so this equation is called Legender's equation, right? Fine. Now we'll reduce this Legender's equation to linear differential equation with constant coefficients by making some substitution. So let's begin the problem. Given differential equation 3x plus 2 whole square into d square y by dx square plus 3 times 3x plus 2 into dy by dx minus 36y equal to 3x square plus 4x plus 1, right? Consider the given differential equation as equation 1. Now, we can write d square y by dx square as d square y using differential operator d, right? Plus 3 into 3x plus 2 into, write dy by dx as dy minus 36y equal to 3x square plus 4x plus 1. Now take y common from all the terms of LHS. We'll get 3x plus 2 whole square into d square plus 3 times 3x plus 2 into d minus 36 into y equal to 3x square plus 4x plus 1. Okay. Now consider this equation as equation number 2 for our convenience. From Legender's procedure, we know that ax plus b can be replaced by e power z, then z will be log of ax plus b, and theta is nothing but d by dz. Okay, and ax plus b into d can be replaced by coefficient of x, that is a into theta. Ax plus b whole square into d square, when we have square we can replace this term by a square into theta of theta minus 1. Since we are having square, so you'll get theta into theta minus 1. We have cube, then you can replace this term by a cube into theta of theta minus 1, since it is cube, so you'll get theta into theta minus 1 into theta minus 2 and so on, right? Well, coming to our problem, let 3x plus 2 equal to e power z. Then z equal to log of 3x plus 2, and theta is nothing but d by dz, and here 3x plus 2 into d can be replaced by coefficient of x is 3 into, since we are having power 1, so we'll get only theta here, and 3x plus 2 square into d square can be replaced by 3 square into, since it is square, so we'll get theta into theta minus 1. Okay. Now the equation 2 becomes this becomes 3x plus 2 whole square into d square can be replaced by 3 square theta into theta minus 1 plus 3 into 3x plus 2 into d can be replaced by 3 theta minus 36 into y equal to 3x square plus 4x plus 1, right? So here we have to replace x, since we are having 3x plus 2 equal to e power z. From this we'll get 3x equal to, just take this 2 to RHS, we'll get e power z minus 2. Now take this 3 to RHS, we'll get x equal to e power z minus 2 by 3, right? So here we can replace this x by e power z minus 2 by 3. So we are writing the equation in terms of theta and z, okay? We'll get 3 times e power z minus 2 by 3 whole square plus 4 times e power z minus 2 by 3 plus 1. This becomes 3 square 9. Theta of theta minus 1 is theta square minus theta plus 9 theta. 3 into 3 theta is 9 theta minus 36 into y equal to 3 times ez minus 2 whole square. You can just split this as e power z minus 2 whole square by 3 square plus 4 times e power z minus 2 by 3 plus 1. Here 1 3 gets cancelled and this gives us 9 theta square minus 9 theta plus 9 theta minus 36 into y equal to 1 by 3 into e power z minus 2 whole square is e power 2z plus 4 minus 4 e power z plus 4 by 3 e power z minus 4 to the 8 by 3 plus 1. Here minus 9 theta plus 9 theta gets cancelled and this gives us 9 theta square minus 36 into y equal to 1 by 3 e power 2z plus 4 by 3 minus 4 by 3 e power z plus 4 by 3 e power z minus 8 by 3 plus 1. So here minus 4 by 3 e power z and plus 4 by 3 e power z gets cancelled. This becomes 9 theta square minus 36 into y equal to 1 by 3 e power 2z plus 4 by 3 minus 8 by 3 plus 1. Let's simplify this. 4 by 3 minus 8 by 3 plus 1 is LCM of the 3 terms. The denominator of 3 terms is 3. In the numerator you'll get 4 minus 8 plus 3, which gives us 4 plus 3 7 minus 8 by 3, which is minus 1 by 3, right? Then the above equation becomes, take 9 common from these two terms, we'll get 9 times theta square minus 4 into y equal to 1 by 3 into e power 2z. Just replace this by minus 1 by 3, okay? I'll take 1 by 3 common from the two terms of RHS, so I'll get e power 2z minus 1. 1 by 3 times e power 2z minus 1. Fine. Now take this 9 to RHS, we'll get theta square minus 4 into y equal to 1 by 3 into 9 into 2z minus 1, which gives us, see, it's not necessary to increase number of steps. You can just directly write 1 by 27 into e power 2z minus 1, okay? Now consider this as equation 2, which is an operator form, say f of theta into y equal to some function of z. I'll consider the RHS part as r, which is a function of z, okay? Where f of theta is theta square minus 4. Now we'll find the general solution to this equation 2 It's equation 3, okay, not 2, sorry. So this is equation 3 using y equal to yc plus yp, where yc is complementary function and yp is particular integral. We'll find yc using auxiliary equation and we'll find yp using 1 by f of theta into r. So now we'll begin with the auxiliary equation to find yc and later we'll go for yp. See, we have reduced the Legender's equation, that is the given differential equation, to an equation with constant coefficients, right? Fine. Now coming to auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of theta, theta square minus 4, right? Let's replace theta by m in f of theta. We'll get f of m equal to m square minus 4. Then the auxiliary equation becomes m square minus 4 equals to 0. We can write this as m square minus 2 square equal to 0, which is of a square minus b square form, right? So we can write this as m plus 2 into m minus 2 equal to 0. Now we equate each factor to 0. When m plus 2 equal to 0, we'll get m equal to minus 2, and when m minus 2 equal to 0, we'll get m equal to 2, right? So here the roots are m equal to minus 2, 2. The roots to this equation. Therefore, m equal to minus 2, 2 are real and distinct roots. We know that when two roots, say m1 and m2, are real and distinct, then yc looks like one constant into e power one root into the variable z plus another constant into e power another root into the variable z. Since we are finding yc to equation 3, right, which is an equation in terms of z and theta, right, which is in terms of z, otherwise here the variable is z, so we'll write z here. Okay, fine. Now coming to our complementary function, yc equals to one constant into e power one root, say minus 2, into z plus another constant into e power another root into z, then yc will be c1 e power minus 2z plus c2 e power 2z. Okay, so we got yc. Now let's find yp. Particular integral is given by 1 by f of theta into r. This is equals to 1 by f of theta is theta square minus 4, r is 1 by 27 into power 2z minus 1. We can write this as 1 by 27 into 1 by f of theta e power 2z minus 1, or 1 by 27 into 1 by theta square minus 4 into e power 2z. We can just write this 1 as e power 0z, since 1 equal to e power 0. E power 0 can be written as e power 0z, right? So we'll replace this 1 by e power 0z for our convenience, okay? Minus 1 by theta square minus 4 into e power 0z. See, this is of 1 by f of theta into e power az type, right? These two terms is of 1 by f of theta into e power az type. Fine. When a equal to 2, see, we have f of theta equal to theta square minus 4, right? If we replace this theta by 2, we'll get f of 2. F of 2 equal to 2 square minus 4, which is 4 minus 4, 0, right? If you substitute theta by, if you substitute theta equal to 2, the denominator becomes 0, so that this total expression becomes undefined, because 1 by 0 is undefined, right? So since f of 2 is 0, what we'll do is we'll just include 1z, and in the denominator we'll find f dash of theta. Okay, f dash of theta is 2 theta, right, which is non-zero. Okay, now coming to the second term, here we have a equal to 0. F of theta is theta square minus 4. If you replace theta by a, we'll get f of 0, which is equals to, just replace theta by 0, you'll get 0 minus 4, which is minus 4 non-zero, right? This becomes 1 by 27 into 1 by theta square minus 4 into e power 2z, since just write 1 by 2 theta. You will get 1z into 1 by 2 theta into e power 2z minus 1 by, since f of 0 is minus 4, which is not 0, which is not equal to 0. So you'll substitute theta by 0 in the second term. I'll write the reason here. Since f of 2 equal to 0 and f dash of theta is equal to 2 theta, which is non-zero, and here the reason is f of 0 is equal to minus 4, which is non-zero. Okay, I'll repeat this again. Here if we replace theta by 2, we'll get 4 minus 4, which is 0, right? If you put theta equal to 2, you'll get 1 by 0, which becomes undefined. So what we'll do is, we'll just find f dash of theta. Okay, we are having f of theta equal to theta square minus 4, then f dash of theta will be 2 theta, which is non-zero, right? So here we can, then in the next step, we'll write 1z into 1 by derivative of, that is f dash of theta, or derivative of f of theta, which is 2 theta into e power z. But in this case, if we substitute theta equal to 0, we'll get minus 4, which is non-zero. So you don't get any undefined term in the second term, right? So you'll get this. So if you feel so confused, we can just find these two separately. Better, right? So here we have f of theta equal to theta square minus 4, right? This is of 1 by f of theta into e power az type, right? Then for a equal to 2, we'll find f of 2, which is equals to 2 square minus 4. Just replace theta by 2. Then you'll get 4 minus 4, which is equals to 0. Since f of 2 equal to 0, so what we'll do is, this becomes, put 1z into 1 by, find derivative of theta square minus 4. That is, we need to find f dash of theta, which is 2 theta, right? So we'll get 2 theta here into e power 2z, which gives us z by 2 into, okay, z, let it be z into 1 by 2 theta into e power 2z. Now consider some function of theta, say some g of theta equal to 2 theta, right? Now replace this theta by 2, then you'll get g of 2 equal to 2 times 2, which is 4, z by 2 into 2. Just replace this theta by 2, because we know that by replacing theta by 2, the denominator will be non-zero, right? Is equals to z by 4 into e power 2z, right? Or we can find 1 by theta of e power 2z. We know that 1 by theta is integral operator. Since 1 by theta is an integral operator, so 1 by theta into 2z becomes e power 2z by 2. You'll get the same thing. Okay. So the result obtained from the first term is z by 4 into e power 2z. Now coming to the second term. One by theta square minus 4 into e power 0z. This is of the type 1 by f of theta into e power az. Here we have f of theta equal to theta square minus 4, right? Now for a equal to 0, we'll find f of a, that is f of 0. Just substitute theta equal to 0, you'll get 0 minus 4, which is minus 4, which is non-zero, right? Since f of 0 is non-zero, so we can dare to substitute theta equal to 0. Then you'll get 1 by minus 4 into e power 0z is e power 0, which is minus 1 by 4 into e power 0 is 1. Since e power 0 is 1, right? This is equals to minus 1 by 4. So the result obtained from the second term is minus 1 by 4. Now coming to yp. Yp becomes 1 by 27 into result obtained from the first term is z e power 2z by 4 minus result obtained from the second term is minus 1 by 4. This gives us 1 by 27 into z e power 2z by 4 minus into minus plus 1 by 4. See, you can take 1 by 4 common from these two terms. You'll get 1 by 27 into 1 by 4 into z e power 2z plus 1. 1 by 27 into 1 by 4. 27 into 4 gives 108. We'll get 1 by 108 into z e power 2z plus 1. Therefore, yp equal to 1 by 108 into z e power 2z plus 1. So we got yc and yp. Let's now find the general solution to equation 3, which is given by y equal to yc plus yp. Therefore, the general solution to equation 3 is given by y equal to yc plus yp. We have yc and yp. Let's substitute it. We'll get y equal to yc c1 e power minus z, it's minus 2z, plus c2 e power 2z, and yp is plus 1 by 108 into z e power 2z plus 1. Okay, 1 by 108 into e power 2z, z e power 2z plus 1. So this is the solution to equation 3, which is in terms of z. But we need to find general solution to the given differential equation. Is general solution to equation 3, right? Since e power z equal to 3x plus 2 and z equals to log of 3x plus 2, we'll write this equation as y equal to c1. We can write e power minus 2z as e power z power minus 2 plus c2 into e power 2z can be written as e power z whole square plus 1 by 108 into z, e power 2z can be written as e power z whole square plus 1, so that we can easily replace e power z in the next step, e power z and z. Okay, this becomes y equal to c1, replace e power z by 3x plus 2, you'll get 3x plus 2 power minus 2 plus c2 into 3x plus 2 whole square plus 1 by 108 into z log of 3x plus 2 into e power z whole square is 3x plus 2 whole square plus 1. Or we can write this as y equal to c1 into 3x plus 2 power minus 2 plus c2 3x plus 2 whole square plus 108, I mean 1 by 108 into 3x plus 2 whole square into log of 3x plus 2 plus 1, which is the required solution, which is the general solution to equation 1 or the given differential equation. Therefore, the general solution of the given equation or equation 1 is y equal to c1 into 3x plus 2 power minus 2 plus c2 into 3x plus 2 whole square plus 1 by 108 into 3x plus 2 whole square log of 3x plus 2 plus 1, which completes the problem. Well, we have seen a problem from Legender's equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.